All right. Yo, yo, yo. Test the audio. Make sure we're working all right. Too high. Selecting automatic. Oh my god. Well, it seemed to work yesterday, so I don't know if I can. Okay. All right, we're going to start round 2 of this game. We got through distance and midpoint yesterday. Today we're going to move on to angle addition, angle bisectors. We got some other stuff we're going to talk about. Eventually we're going to transformations. Some of this we didn't cover in class, just we ran out of time, couldn't cover it all. But that doesn't mean I'm not going to go over it. I don't expect you to know it on the final, but extra knowledge, get extra points. So questions will be on there. All right. So let's look at number 15. We have this angle. Then we have this angle. And if we put those two together, a piece plus a piece equals the whole angle. Okay? So that's what we're going to focus on for this problem. So we are going to do the first piece. I'm going to call it OEM. And that's angle OEM plus GEM. So angle GEM equals the whole angle OEG or GEO. Now, when you look at the information that's given, they tell you what GEO is. That's 127. So we're going to put 127 there. They tell you what OEM is because there is a box here. This box from our angle classification stuff that we did, you need to know that that's a right angle, and the measure of a right angle is 90 degrees. So once we figure that out, we can figure out what the missing measure is, GEM. Okay? Angle GEM. We're going to subtract 90 from both sides. We're going to get 37 as our solution. So that angle GEM equals 37. Okay. So that's as simple as it gets for this problem. Don't overcomplicate things. Just write down what you know and what you need to know. All right. Next thing, you need to know this vocabulary word, bisects. Bisects means to cut into two equal pieces. So if this CBA gets cut into two equal pieces and this piece over here is 65 degrees, then this has to be 65 degrees. That's what a bisector means. It means it cuts it into two equal pieces. Now, depending on what the question's asking, make sure you answer what the question's asking. Now, 16 is asking what is the measure of CBD. So you just say 65. But it could also have asked, what is CBA? And then that's when you double 65 and make it 130. So be careful. Make sure you are answering the proper question and picking the proper answer. But that's, once again, how you're going to break down that question. But you have to know that bisects means to cut into two equal angles, or cut the segment into two equal segments, or the circle into two equal half circles, like whatever you're bisecting. So it's not necessarily always going to be angles. You can bisect anything. It just means to cut it into two equal. Hey, what's going on, Beck? I'll do a little geometry review. All right, next one. we are going to use the angle addition postulate again. So we are going to say that the first angle right here, PQS. Oh, thank you for the like too. You're the best. Thank you. So angle 1 plus plant, welcome. Angle 2 equals the whole angle. So that's going to be angle PQR. So when we put that, we're going to do angle P Rainey, welcome, PQR. Okay. Now all we need to do is substitute in our given information. So we would call this the angle addition postulate. Okay. So if you want to give some justification for each of your steps, so this is the angle addition postulate, then we can use substitution because we know angle 1 is 2x plus 12 plus angle 2, which is 47. I can't wait for you to help CC with math. Me neither. Me neither. And it'll be easy because we could just stream and, you know, like I do it. Actually, there's a good plug right there for me. Through Discord. I have my own Discord channel where we set up private lessons, and what you'll do is you'll post your questions that you have. This was my calculus stuff that I was doing, and literally it's because I'm trying to live. No, sorry. Okay, let me get out of there. Jesus, getting me in trouble now. We would join that together though, and I could share my screen, and it's like we would have our own personal live session going on, not necessarily live for everyone to watch. And I don't want to put the stress on the student when I'm doing these tutoring sessions that it would be blasted over, you know, TikTok, because every kid in my class knows what TikTok is. Welcome, Complex. But we could have that private session one-on-one where they could ask questions, get their answers. You know, we can go through homework problems and really break down problems for them. So if anyone's interested out there, join. This link is in my TikTok, and you can join this Discord tutoring channel. And once you go through the rules and approve those, you'll pick a role, whether you're a student or parent, and then you'll get all this other information for you. And I do these live streams where actually people could post their questions in here and I can answer them as well. Not just doing stuff for my students, but I could do stuff personally for you as well. So yeah, once Cece gets there, we'll just hook up the chat and get going. So yeah, it'll be awesome. All right, so back here we did substitution where we plugged in, and welcome Anil. We plugged in what the measure of angle 1 was, 2x plus 12. And then angle 2, 47. And now we're going to put PQR in, which is 5x minus 4. Now, for my students, I want to underline the variables and draw the line down the middle of the equal sign, breaking it into two sides of the equation. Now, normally, my highlights are both on the same side, and we talked about that at combining like terms. Awesome. Good night. Let's see ya. Thanks for stopping in, though. Appreciate it. Appreciate the like. You're the best. But because they're on opposite sides, now we have to do a subtraction property of equality. So we're going to subtract 2x from both sides of our equation and do that. I'm not going to do that because I want you to try and do some of the work for yourself. But if you get stuck, ask a question in class, okay? So what we would do is start to subtract 2x from both sides and move all the x's to one side, and then we want to put all the numbers on the other side. So that's how you really want to push this problem into legit solving it. Okay, in the figure, not drawn to scale, MO bisects. So we're going back to this vocabulary term. Bisects means to cut into two equal angles. Carlos, welcome. So if I know LMN, so that's the whole angle, and I know NMO. Now this is the beauty of it. If I know NMO, this first angle is x plus 47. I technically know what the other angle is too, because bisects means that cuts it into two equal pieces. So I know this one is x plus 47 as well. So this piece plus that piece equals the whole thing, which is 9x minus 11. So then we can start to set that problem up and really start to solve it, okay? I don't want to do that because I want them to have some practice in it, but this is what the setup's going to look like. We would say LMO, so angle LMO plus angle OMN equals angle LMN. Okay, and then I would have x plus 47 and then x plus 47 equals 9x minus 11. Use your highlighter, underline the variables, and then draw a line down the middle equal sign. Now that I have two of them that are on the same side, combine like terms, and I would get 2x plus 94 equals 9x minus 11. Then I'm going to subtract 2x, and that's as much as I'm going to say. Polo, welcome. That's as far as I want to go with that problem because I really want them to try it on their own. So that gets us through the angle stuff. Now, we're talking about inductive and deductive reasoning in this one. And when I do stuff like this, there's a difference between inductive and deductive reasoning. Deductive really has more of, they're telling you exactly what they want you to do. They're telling you these two are a linear pair. So by knowing the definition of linear pair, I could use deductive reasoning and say angle 1 plus angle 2 equals 180 degrees, because what they're saying is one angle plus the other angle make a straight line. Okay, that's what a linear pair is. So this could be angle 1, this could be angle 2. Now, we could have a plethora of these situations. It doesn't necessarily mean angle 1 is the acute angle. You could have a whole bunch of different scenarios for deductive reasoning, but there is some knowledge that goes along with it. Inductive is making an educated guess. So it's really, if you use logic, it's really probably inductive reasoning. Like this one. From 14 to 11, I'm going to subtract 3. From 11 to 8, I'm going to subtract 3. From 8 to 5, I'm going to subtract 3. That's deductive reasoning because I'm using something that's a pattern that's happening every single time. So now that's going to be 2 as my next number. Okay? Inductive reasoning, if it's a weekend, then it's Saturday. That's inductive reasoning, because that's kind of an educated guess. It's not really like last Tuesday I ate macaroni and cheese. The Tuesday before that I ate macaroni and cheese. The Tuesday before that I ate macaroni and cheese. Today is Tuesday. You're going to make an educated guess based on some information. Okay? Identify the hypothesis and the conclusion. An angle measures less than 90 degrees if the angle is acute. So my hypothesis, if something is happening, then the conclusion happens, okay? So you're always looking kind of for that if-then statement. So your if actually is the hypothesis, and your conclusion is actually what it turns out to be. So when you're doing these types of things, if it says identify the hypothesis, that doesn't mean it always comes first. It's that if statement. If the angle's an acute, that's your hypothesis. Your conclusion is the fact that it is an acute angle means that it has to be less than 90 degrees, because that's the definition of what an acute angle is. So for this one, it's a little tricky. They kind of flip-flop the hypothesis and conclusion. All right. This one, we need to use a lot of justification in what we did. So if 3x equals 18, then x equals 6. What property could we use? What would we do to tell us that? Well, we could do division, property of equality. Because if I divide, both sides by 3, then I get my answer is x equals 6. Okay? If C is in between A and B, then AC plus BC equals AB. This is knowing that this is the segment addition property. And a lot of this is you have to know these types of definitions in geometry. Oh, God, I hate this one. If 8 equals x, then x equals 8. And when you think about this, are you making a mirror of the situation? If that's the case, that is the reflexive property. If you're making the mirror of it, that is the reflexive property. It comes in handy here and there. Most of the time to get something to look the way you want it to, as opposed to Madeline, thanks for coming. The tough one is symmetry. Cable, welcome. Measure of angle 1 equals measure of angle 2, and measure of angle 2 equals 80, then measure of angle... Oh, this is a great property. So this is what I call the middleman. I talk a lot about it with phones, buying phones. A lot of times some people will go to your AT&T, your Best Buy, your Verizon to buy your iPhone. And what I say is cut out Verizon and go straight to Apple. That is cutting out the middleman. Ronaldo, welcome. So if we cut out the middleman, that is actually what we call the transitive property. So we call that the transitive property. We're going to get rid of the one that is doubled. So you see the angle 2. It's almost like substitution, because I know the measure of angle 2 equals this, and I know the measure of angle 2 equals that. So set them equal together is sort of like substitution. If I know x equals 8 and 3x plus 2 equals what, I'm going to substitute that 8 in for x and solve that out. That's sort of what they're trying to do here, but because it's repeated twice, they use a thing called the transitive property. Moranti, welcome. All right, so number 23. The first thing they do is they write out a problem. Anytime the book, the test, whatever situation comes up mathematically, if they give it to you, that is given information. If it's in the picture, that is given information. That's given information. I know that the only reason I know that information is because it's written on my paper. And I didn't write it. The problem did. So if that's the case, you've got to call that given information, okay? Now, the next reason they gave was distributive property. So that means I need to distribute this 4 inside. And when you distribute, you're multiplying. 4a plus 16 minus 8 equals 44. YB, welcome. Now, they tell you you're going to use the substitution property. So that means, Red Hood, welcome. That, oh, thank you, Red Hood, for the like. I appreciate that. So A equals 9, which means I'm going to substitute 9 in for that A. And I'm going to put the 9 there. And if there was a step 4, I would show that 36 plus 16 subtract 8 hopefully comes out to be 44. And I would maybe call this multiply, because that was what I just did. I just multiplied 4 times 9. And then I could call it combine like terms. And just combine these and show that 44 actually does equal 44. And it does work out that way. All right. So measure of JKL. Measure of JKL equals 116. It says it right there. The measure of JKM equals 6x plus 8. Shows it right here in our picture. And then the measure of MKL L equals 2x minus 4. Says it right there. All of that is given information, because without that problem and without all of that information, I would not know any of that. So if it's written on your book, on your test, whatever it is, we consider that given information. Even if it's in the picture, it's still given information. Now, what did they do next? They wrote the, I was going to do a faux pas right there. I wanted to do segment addition postulate, but it's not segments. We're talking about angles. Angle addition postulate. And what I tell my students is we did a piece plus a piece equals the whole thing. So if I have the first angle plus the second angle and I add them together, it creates that whole angle. So we always do a piece plus a piece equals the whole thing. Just a little kinesthetic action going on for you so that you can get movement along with your education. Tying things to movement is supposed to be such a great learning tool. Norman, welcome. All right, moving on. Oh, did we already? Where am I at? Hold on, sorry, I gotta minimize. Let's see. Oh, I'm already on page 3. Sweet. Okay, so let's go. Oops, go here. So the last part, we really didn't get to in class, and that's okay. And I'm okay with that, but I would like to still cover it, because these are bonus questions, especially on the final, that you could easily get right if you know what the transformations are. And there are 4 of them. There is a, what we call a translation. There is a rotation. Just welcome. There is a reflection. Tori, welcome. And then there's a dilation. Okay, with the translation, all we're doing is right or left, up and down. So we're just moving, shifting, like what happens with it though, and the beauty of it is if I translate something, you can still see exactly the same figure the way that it's intended. So if the figure doesn't if it stays in the same orientation, we'll say, if you can see the same orientation, then that means that you're doing a translation. It's just getting shifted one way or another. Now, if I start to, oh, no worries, man. I appreciate you stopping by. Or woman, I apologize. Thank you, though. If you see a different orientation, though, and a circle is difficult because but you can definitely see the insignia on this side. Once I flip it over, there's no insignia. So if that's the case, that becomes a reflection. We're doing what I call flipping it over. So flip over. A rotation. So once again, if I do this and I move it around, you can see the orientation of my shape still stays the same. Once I start doing this, now I'm doing a rotation. I'm changing the orientation of my figure. Am I making it bigger or smaller? No, still a roll of tape. I can't change this. But what happens is I start to make it bigger or smaller. Okay. Hi, welcome. So as I'm doing this, the rotation is what we call a spin. And then probably my best example is going to be this. So it's just a zip tie. But if you look at a zip tie, you have right here, what I'm going to do is start changing the size of that opening of my zip tie. And it's getting smaller, obviously. So this is what we call a dilation. It's when you start to change the size of what your figure was. So anytime you see 2 different size shapes, that is going to be what we call it a stretch or compress. Stretch or compress. That's going to be a dilation. It's going to be larger or smaller. Oh, I'm sorry, I can't see that on the. Let me do this real quick. on the phones. So we talked about a translation moves it right or left, up and down. A rotation is a spin. Reflection is a flip over. And then dilation is a stretch or compress. Okay, so if that's our case, when we look at this, do you see how this figure, and there's what we call a pre-image and then an image. So our pre-image is where you start, and that's kind of like pre-game workout, it's before you do something to it. So the image, think about a camera. Once you take an image on your camera, it's not actually the original image, it's a copy of what you saw. So when they talk about an image, sometimes you're like, yeah, that's where you start, but it's actually not. It's the pre-image that is where you want to start. So this figure, being our pre-image, gets put over here on our image, and if you think about it, we're flipping it over. So that is going to be, oops, don't have my pen, a reflection. Now, obviously this one, here's our pre-image, it's the pink one, and then the blue one is our image. Now, why did I know that? Because there are these primes on these letters. That's what they call them. They call them primes. You would think what? Hyphen, when you do it's kind of a hyphen. It's kind of that same idea, but they call it a prime in math. So our image is the primes that happen afterwards. So we have our pre-image and then we have our image. So what's happening is our pink triangle is getting smaller. So we know this. Ashley, welcome. Ash, welcome. A dilation. Sorry, it's been a long day, but I want to get through this because I want to get a new video for my students for tomorrow. Because we're taking a test, but once they're done, they should be able to watch and start to work through this packet. This is our review packet for the final. Once you see C, that's how we have a roll of tape and we start to twist it, or I guess I should twist it this way to get that boom to boom, that triangle to shift. So they talk about pre-image, image. That's going to be a rotation. And then lastly, we just shifted it to the left. Jacob, welcome. And then shifted it down. That's a translation. And what I think really kind of the easiest thing to see with translations is the arrow's pointing this way. It's still pointing that way. Like we didn't move it so that it points up. We didn't move it so it points the other direction. Like the orientation of your figure just stays the same direction. We're just moving it from where it started to where it finished. Ooh, excuse me. All right. What number does the hour hand point to when they're transformed by a reflection over the y-axis? So here's our, I'm going to call this our small hand. If we reflect it across the y-axis, so our y-axis is this one. Red, welcome. That means that our new one is going to be over on this side, and it's going to point to the 10. Okay. Now, if I could do this, I do this with my students in class because they have Chromebooks. Take your Chromebook and shift it 90 degrees and shift it 180, then shift it 270 and then flip it back over to 360. TJ, welcome. So if you have this, all you need to do is rotate it one click, either clockwise or counterclockwise. Well, if I'm going clockwise, remember the clock does rotate this way. So now that click, that rotation, and remember, this and this get rotated down to here. So be careful because it's actually going to point to the 5 on a full click rotation. And then rotating 180, you can go directly across to the other side and it will be an 8. Because you want to make a straight line with your figure when you do that rotation. Carson, welcome. All right, a figure lies in quadrant 2. of the coordinate plane. Nixon, welcome. What coordinate will the image lie if we reflect over the x-axis? So if we reflect over this axis, so we're going to flip it over, it's going to wind up down here in quadrant 3. Jake, welcome. Rotate 270 degrees counterclockwise. So we're going to rotate this way. And if we do that, here's 90, here's 180, here's 270. So it's going to be up in quadrant 1. All right, so draw our figure. Hey, baby.
Keep an eye on the Instacart thing. We're
Okay.
just waiting for one more item to hopefully be replaced. Then he should be checking out. There's 2 baskets upstairs. One has dirty clothes and one's just a basket with a suitcase.
Okay.
I need to come down at some point tonight or tomorrow.
Okay. Love you. All right. Mohan, what's going on, baby? Good to see you. All right, so draw the figure, all lines of symmetry. Explain why those are lines of symmetry. So when we talk about lines of symmetry, we can literally fold this figure in half. So one of the obvious ones, GP, welcome. One of the obvious ones is you can go right down the center. But there are actually a couple others, because if you flip this star just a little bit, couldn't you fold it right here? And then couldn't you fold it right there? And then how many points does a star have? Well, it's got 5. So technically you can fold this 5 different ways and have it fall on the same of its figure. Okay? Because if you can do it the first way, all the other ways are going to work just the same and just as well. Because we can fold it right down the center. If we fold this right down the center, this point of the star is going to fall on this one. This point of the star is going to fall on that one. And if we can do it with that, we could do it with any point. It might not look as neat, or maybe you don't see it as well, but it can still be folded. Okay? So if that's the case, that's how you technically find lines of symmetry. Okay? Z, welcome. Gain, but why I can take a loan with gains? But why I can what? Oh my god. You all right. So how many lines does it have? It has 1, 2, 3, 4, 5. Oh my god, yeah, I'm ignoring you at this point. All right, now give all angles of rotation of symmetry less than 360. If, like, let's take, let me make sure I can put it on the phone one as well. Here is a figure where if I spin it, the only way to get it to fall back on itself is to go all the way around my figure back to 360 degrees. The roll of tape is definitely a good example of this. Like, I can't spin this except one rotation to get it back to here. Okay? That is how symmetry works. And if it has rotational symmetry, it means that it will eventually look like this before I get back to the 360 degrees. If it doesn't have rotational symmetry, it means that the only time it looks like itself is at 360 degrees. Not welcome. So this one has no rotational symmetry. Why am I actually paying attention? Because this is great information for you to know. Now, with other figures, just trying to find something laying around here. Here we go. If I rotate this, see how that looks, Mister? Welcome. Sharky, welcome. And see how that looks the same, and that looks the same, and that looks the same. this has rotational symmetry because I can get the figure to look like itself before I spin it all the way 360 degrees to get it back to here. Okay, I can make it look like that here, here, here. So that's what they call rotational symmetry. So can I rotate this so that this point rotates over here to this point? And then couldn't I rotate it again so that it becomes that point? And rotate it again so that it becomes that point? And rotate it again so that it becomes that point? So at this juncture, I have spun it. We're going to do 360 divided by 5. And 35, what that's 7, 2. So that means this is a 72 degree rotation. Yes, welcome. And then this is going to be 144 degrees. Then you're going to add another 72 onto it, another 72. And then once we get back to 360, it's almost like you started at the very beginning. Bean Trill, welcome. You don't have to count that one. So we have 1, 2, 3, 4. We have 5 points, but we don't have 360. Remember, that's just going back to the beginning. So there's one at 72. There's one at 144. There's one at, what's that going to be? 216 degrees. Double check my math, peeps. Help me out. This will be 288. Because 7 and 1, 6 and 2, 88. Okay, and then when we do another 72, that's when we get back to 360. So there's rotational symmetry at 72, 144, 216, and 288. All right, I'm out. See ya. You know what? I'm out. Well, I'll be out in just a second, but I'm out as well because these are all the problems that I wanted to cover for my students. Easy. Yeah, it is easy. No, it's not. But once you know how to do it, it's not as complex or it's not as difficult as one might think. Okay? So keep practicing, keep getting ready. Hopefully most of you are going to take your finals within the next week or two. But check this out. Once you have a little practice, it does become a little bit easier. Quick plug for myself. This is my Discord tutoring link. You will see this pop up first before anything else. Read the rules, please. React to them. If you want, you can watch a video of how to do it. Roles, you're going to pick a student or parent, and then all of this other stuff is going to come up where you can see my socials. You can see my private lessons and how you can pay for those if you want. Notifications for any time I post a video or I post something on TikTok. It doesn't post when I go live. I have to figure that one out. Another day, another time. Shrek, welcome. User, welcome. But I posted the first one of my review. Where is it? Here's my review that I did for my students. So we did kind of points, lines, and planes. We did the segment addition postulate. We did midpoint and distance formulas here. And then we talked about angles and how to find angles on a protractor. Then today we started out with angle addition postulate and bisectors. We talked about inductive, deductive reasoning. We did a lot of justification in this area. And then we talked about our transformations. Gabby, welcome. Peanut, welcome. I appreciate everybody stopping in. We're going to go into this stuff tomorrow. So, and hopefully finish a lot of this up. Might need 2 days, but hoping maybe I can get it all in tomorrow. So, that will do it. Oh, once again, the Discord, there's a link in my TikTok bio. But really what I'm hoping for is when I do these live sessions, and I usually do them on Mondays, but with final exams coming up, I really want to make these. Oh, wow. April, Sarah, Sophie, welcome. I'm sorry I'm missing some of these people. I appreciate you all stopping in. But I go live every Monday, And what I want to have happen is this look like this. This is my private tutoring. And I did a lot of calculus. So when I was doing this, she would post the questions in here, and I'll say she because it was one of my former students who I was working with in calculus. And she would post the questions in here, and then we would work through them together. But if you post your questions in this questions tab, I can literally work them out online, whether, I mean, I don't have to say it's from you. I just copy paste into my whiteboard and just do it for you. So wow. Bobby, thanks for stopping in, and this great emoji. Thank you for coming in. That's pretty sweet. But you could easily post a question in there anonymously and get it answered. Okay. So please feel free to join. Doesn't cost anything. Only if you want private lessons, does it? Or private tutoring sessions. Just, keep it clean, keep it respectful. But really want to kind of jump this up. I've got 20 already, and I want this to grow just as much as my TikTok, which is at 3105. I'm working on 10K. So if you're here, hit that follow button. Sometimes this makes me laugh because I'm truly doing this. I didn't expect to have people stop in and join and say hi, other than people that I know. So it's amazing that you're here and stopping in. I really appreciate it. So please drop a follow if you'd like. You don't have to. But it helps me, and it helps me get out to a wider audience and really kind of make math not as scary as it is. User welcome. Because that's really my ultimate goal. When I started this whole thing, I just want to make math not scary for people. A lot of the times people are like, I hate math. But you don't really hate math. You hate the fact that you're confused, because this is what math does. It just builds on top of each other. Well, if you don't have a foundation, it all crumbles because it's so difficult. But if you just start breaking down some of the basics of each thing, like, oh, I can look at this and go, I know it's getting bigger. Well, once you know that vocabulary term, you can start to use it. And then when you start to build these building blocks, you start to add these blocks. And the next thing you know, you do have a foundation and you really do know some math and can be successful. All right. Because that's my goal. I want everybody to be successful and think math is easy, because it's just a game. And I love playing video games, and I love games. So make it a game and figure it out. All right. Until next time, have a blessed night. Thank you for stopping by, and hit that follow button. All right. Have a good night.